Good afternoon, learners. My name is Mutlalepula Shadrack Somchato, a geography teacher in Sasamala School in Siame, Harrismith. Our topic today will be the mid-latitude cyclone and a tropical cyclone. Right away, we need to start with the mid-latitude cyclone. Sometimes it is called the frontal depression. Others, they call it a temperate cyclone. But today we are going to talk about as the mid-latitude cyclone. Now, before we could talk about the mid-latitude cyclone, we need to go to the place of origin, where it originates, that tropical cyclone. Its place of origin, the place of origin of the tropical cyclone, as we can see the diagram, you will remember that the diagram indicates the pressure belts. Remember that at the equator, we have an equatorial low pressure belt. At 30 degrees north and south, we are having the subtropical high pressure belt. And at 60 degrees north and south, we are having the subpolar low pressure belt. Now, it is at this point, at 60 degrees, where we are having the origin of the mid-latitude cyclone. Look at the westerlies here. Remember that we are having a high pressure belt here, and we are having again the high pressure belt at the polar. So the air is moving from a high pressure area to a low pressure area. And this side again, the air is moving from a high pressure area to a low pressure area. This will remind you of the pressure gradient force. It is because of that pressure gradient force that the air is moving from the high pressure area to a low pressure area. Now the surface wind resulting from that, the one from the subtropical high pressure belt to the subpolar low pressure belt, the surface wind, you'll remember that it is called the westerlies. It is called the westerlies because of the Coriolis force. Can you see the deflection of the air from the subtropical high pressure belt to this subpolar low pressure belt? The air is becoming deflected. The force that causes the air to be deflected, it is called the Coriolis force. And according to the Ferrel's law, we are saying that the air in the southern hemisphere will be deflected to the left, and in the northern hemisphere, the air will be deflected to the right. So in this case, when the air is deflected to the left, then the air seems to come from the west. Hence, we name it the westerlies, according to the direction from which they blow. The same with the polar easterlies. We name them the polar easterlies because of the deflection. After being deflected to the left, then it seems this air comes from the east. Hence, they are called the polar easterlies. Now, the place of origin of the mid-latitude cyclone, it is around the 60 degrees, as we have seen. This is where the mid-latitude cyclone originates, at 60 degrees north and south. Number two, the place of origin, it is along the subpolar low pressure belt. Remember, this is the subpolar low pressure belt. Therefore, it is the place of origin of the mid-latitude cyclone. This is where, again, the two air masses that are having the different temperatures. We are having the cold polar air, the air from the pole, South Pole, which is the polar easterlies. This air is colder than the air from the subtropical high pressure belt, which are called the westerlies. Therefore, we can say the westerlies, in terms of the temperature, they are warmer than the polar easterlies. Now they are meeting here in the polar front. Therefore, the front resulting from this, it is called the polar front. Now, let us clarify this. The place of origin of the mid-latitude cyclone, it is at 60 degrees north and south. It is along the subpolar low pressure belt. It is where the cold polar air meets with the warm tropical air. That answers the area of formation of the mid-latitude cyclone. Learners are advised to know exactly where the mid-latitude cyclone originates. At 60 degrees north and south of the equator, along the subpolar low pressure belt, where cold polar air meets the warm tropical air. The front. It is important, again, one, to know the definition of the front. A front, it is a zone where two air masses of different temperatures meet. Because at 60 degrees, that is where the two air masses with the different temperatures meet. It means we are going to have a front here, which is a zone where two air masses of different temperatures meet. This will bring us to the first stage of the mid-latitude cyclone. Now, we are having 4 stages of the mid-latitude cyclone. The first stage, or the initial stage, it is where you see from the diagram before that we are having the warm air moving from the west to the east, and which are the westerlies. And we are also having a cold air from the poles to the subpolar low pressure belt. And now in this case, we see the two air masses moving parallel to one another in opposite directions. You can see that the two air masses are moving parallel to one another in opposite directions. The warm air is moving towards east. The cold air is moving towards west. And they are being separated by the front, which is in this case called the boundary zone, meaning that it separates the two air masses. Again, when you look into this, there is no movement of air across the line of separation. The cold air doesn't cross the separation line to the warm air. And the warm air also cannot cross over to the cold air. So we are saying, one, the two air masses, they move parallel to one another in opposite directions, as you have seen in this case. That one is moving that direction, and the polar easterlies this direction. So the two air masses, they are moving parallel to one another in opposite directions. Number 2, we are saying there is no movement of air across the line of separation, either from the cold zone to the warm zone or vice versa. This is the situation at the subpolar low pressure belt. The situation will remain like this until the disturbance comes. The situation will remain like this until the disturbance happens. When the disturbance happens, either, which is the acceleration of air mass of one of the two air masses, or the disturbance can be the shape of the coastline, or the disturbance can be the mountain ranges, or the disturbance can be the contrast between land and sea temperatures. We are saying the situation at the subpolar at 60 degrees north and south will remain like this until the disturbance takes place. The disturbance can either be the acceleration of air movement in one of the two air masses, or the disturbance can be the shape of the coastline, or the disturbance can be the mountain ranges, or the disturbance can be the contrast between the land and the sea temperatures. When that happens, when the disturbance takes place, then the local decrease in pressure in the form of a tongue of the warm less dense are penetrating to the area of the cold. Now in this case, we are having the formation of the mid-latitude cyclone. The formation of the low pressure cell can be seen here. The diagram is not the same as that one. Why? Because the disturbance has taken place. Before the disturbance, the diagram will be like that one. But after disturbance, everything will change. Meaning that on the western side of the low pressure cell, where it originates, on this side, on the western side, you see that the air is no more moving towards west. Now the air changes direction. It starts to move towards north, as we can see in the diagram. And then on the other side, the cold air retreats on the eastern side of the disturbance. The cold air retreats, allowing the warm air also to move towards south. Whereas in this case, the cold air is moving towards north, and the warm air on the other side will tend to move towards south. Now you can see that the circular motion of air becomes developed. Now this, it is called the initial stage of the mid-latitude cyclone. The second stage of the mid-latitude cyclone, it is the mature stage. In the mature stage, that is where we can see the different features of the mid-latitude cyclones, the features that were not there in the initial stage. In the mature stage, the features can be clearly seen. Look at this one. This, it is a feature of the mid-latitude cyclone, which is called the cold front, as we can see. The name of this feature, it is called the cold front. Why is it called the cold front? It is because the cold air is approaching the warm area. The cold air is approaching the warm area. So because it is the cold air that is approaching this, it is called the cold front. It is important that the learners should know the name of this feature. It is the cold front. On the other side, we are having another feature of the mid-latitude cyclone. The feature is the warm front. The warm front is different from the cold front. You can see in the feature here. The cold front is sharper than the warm front. The warm front is a semicircle, as we can see. It is not sharper like the cold front. So this one is called the cold front, and then this one is called the warm front. Apart from the polar front that we have seen in the beginning, now we have the cold front and the warm front. Sometimes learners, they confuse the two. So it is important that we need to know exactly the names of these fronts, the cold front and the warm front. Now, the space between the cold front and the warm front, where there is a warm air, that area, it is called the warm sector. The warm sector, it is the area between a cold front and the warm front in the warm air. We call the warm sector. Now, between the warm front and the cold front, where we have the cold air, that area, it is called the cold sector. Learners, you need to know the features of the mid-latitude cyclone in the mature stage. They can be well seen. The cold front, the warm front, the warm sector, and the cold sector. In this stage, you are saying the mid-latitude cyclone, it is in its mature stage. Another stage from the mature stage of the mid-latitude cyclone, it is the occluded stage. This is the stage after the mature stage. In the occluded stage, that is where we see the difference. Look at the warm sector. The warm sector, it is now smaller than in the mature stage. Why? Because the cold front catches up and overtakes the warm front, as we can see here. The cold front catches and overtakes the warm front. When that happens, then the warm air of the warm sector is isolated from the ground. When the cold front catches and overtakes the warm front, what happens to the warm air? The warm air becomes lifted up and be isolated above the ground. When that happens, the term used there, it is called the occlusion. Occlusion, it is the term used when the cold front catches and overtakes the warm front, causing the warm air to be isolated from the ground or to be lifted from the ground. The term used, it is the occlusion. Now, the resultant front from the occlusion, it is called the occluded front. Note, to the cold front and the warm front, we have now added another front, which is called the occluded front. Occluded front, it is formed when the process of occlusion has taken place. Question: what is occlusion? Occlusion, it is when the cold front catches and overtakes the warm front, causing the warm air to be isolated above the ground. So from the process of occlusion, then we have the occluded front. Occluded front, it has the sign of the warm front and a sign of the cold front. Now it is important for the learners not to confuse the different stages of the mid-latitude cyclone. The initial stage, the mature stage, and the occluded stage. Get all the marks that you can have from this section. The stages of the mid-latitude cyclone. Now, after the occlusion stage, then we are saying the mid-latitude cyclone will dissipate. The mid-latitude cyclone will dissipate. The dissipate stage of the mid-latitude cyclone. What happens is that the system ends up as a little gust of the cold air at the ground level, and then all the warm air has been lifted high above the ground. The cyclones weakens and the upper level winds break out. It breaks the cloud apart. Then note, the precipitation decreases, and eventually stops completely. It is what is happening in the dissipating stage. We are saying, under the dissipating stage, all the warm air has been lifted. It has been lifted above the ground. And then the cyclone, it weakens, and upper level winds break up the cloud apart. And then the precipitation decreases and eventually stops completely. Those are the stages of the mid-latitude cyclone. The first one is the initial stage, as we have seen in the diagram. The initial stage. The second one, it is the mature stage. The third one is the occluded stage, and then the dissipating stage. That is the mid-latitude cyclone. Let us look into the characteristics of the mid-latitude cyclones. The characteristics of the mid-latitude cyclones. The qualities of the mid-latitude cyclone. The qualities of the mid-latitude cyclones. One, we are saying the air circulates clockwise in the southern hemisphere. The air circulates clockwise in the southern hemisphere. As we have seen, when the mid-latitude cyclone is developing, the air was circulating clockwise. That indicates that the mid-latitude cyclone, it is a low-pressure cell. A mid-latitude cyclone is a low-pressure cell. One, the air circulates clockwise in the southern hemisphere, meaning that in the northern hemisphere, the air will be circulating anti-clockwise. Number two, we are saying the system moves from west to east. The movement of the system, it is from west to east. This is where now the learners, they like to confuse the two. We are saying the air around the system is circulating clockwise in the southern hemisphere. And the whole system moves from west to east, meaning that the mid-latitude cyclones, after being formed, it will move from west to east. That is the direction of the whole system. The reason why the mid-latitude cyclone is moving towards east, it is because of the westerlies. Remember that the westerlies, it is the air that moves from west to east. So because of the westerlies, these are the winds that pushes the mid-latitude cyclones to move from west to east. This is the reason why the system moves from west to east, because of the westerlies. The life cycle lasts from 2 to 5 days. The life cycle of the mid-latitude cyclone, from its development to its dissipating stage, its life lasts from 2 to 5 days. That is the lifespan of the mid-latitude cyclone, from 2 to 5 days. The mid-latitude cyclones, they usually occur in families of 3 or 4 members. The mid-latitude cyclones usually occur in families of 3 to 4 members. You can see in this diagram that we are having how many mid-latitude cyclones? Number 1, 2, and 3. These are the 3 members of the mid-latitude cyclones. It is only the mid-latitude cyclones that occur in families of 3 to 4. This is the first mid-latitude cyclone, this is the second, and this is the third. It is in this case that a learner should know which one came first. The oldest being the furthest south. Where is our south? Here is our south. The north is up there. So in this case, this one, it is the oldest mid-latitude cyclone. Why do we say that? Because it is the furthest south. The recent one, it is the one of the furthest north, as you can see. Even if the developmental stage is not the same, you can see that the one on the furthest south, the oldest one, it has reached the occluded stage. Can you see that? Yes, it has reached the occluded stage. The second one, it is in its mature stage. And the third one, it is in its initial stage. Now you can see that the 3 members of the mid-latitude cyclones, they are in the different stages, meaning that this one came first. The last one, it is this one. So we are therefore saying the mid-latitude cyclones, they occur in families of 3 or 4 members. As we can see. The other point about the mid-latitude cyclones is that these cyclones, they develop throughout the year. The mid-latitude cyclones takes place or develop throughout the year. In summer, they are there, and in winter, they are there. They develop throughout the year. The mid-latitude cyclones, they develop throughout the year. Now, the mid-latitude cyclones, they reach South Africa more often in winter. Mark that. They reach South Africa more often in winter, when all the pressure belts and the wind systems have slightly moved to the north. Remember, all the systems, they shift according to the seasons. When the sun is on the Tropic of Cancer in the north, then all the systems, they shift to the north. In summer, when the sun is directly on the Tropic of Capricorn, all the systems shift to the south. So because of the shifting of all the systems, we are saying in South Africa, these mid-latitude cyclones, they affect the land during winter. Let me show you a diagram for that. Look at this diagram. Do you see the synoptic weather map? This is where the land is. This is where the land is. And then look at the features of the mid-latitude cyclone. Look at the cold front. The cold front is right on the land. This simply means it's during winter. Why? Because we have said the mid-latitude cyclones, they affect the land often in winter. That is why you can see these are cold front moving over the land. It means all the system has shifted towards north. That is why we are being affected by the cold front. Look at this diagram. Do you see we have another synoptic map here? We see the land, just like before. This is the land of South Africa. Look where the cold front is. The cold front is further to the south, unlike in winter. Look at in winter. The cold front moves over the land. And during summer, the cold front passes further south of the land. It doesn't affect us. The mid-large cyclones in summer, in most cases, it doesn't affect the land. Why? Because it has moved further to the south. Remember, this is because of the shifting. In summer, all the systems shift towards south. That is why we are not affected by the cold front in summer. Now, in winter, all the systems, they are being shifted towards north. That is why we are having the cold front passing over the land. Let us go again. The characteristics of the mid-latitude cyclone. We said, number one, the air circulates clockwise in the southern hemisphere. This gives you the idea that a mid-latitude cyclone, it is a low pressure cell. Two, the system moves from west to east because of the westerlies. I said this is where most of the learners get confused. When the question says, explain the circulation of air in the system, then the circulation of air in the system is clockwise. Now, when the question says, what is the movement of the whole system, then we are saying the system moves from west to east. And the reason for that being because of the westerlies. The mid-latitude cyclones, after being formed, they are being pushed from west to east by the westerlies. The life cycle of the mid-latitude cyclones, they last from 2 to 5 days. It has the lifespan of 2 to 5 days. The mid-latitude cyclones, they usually occur in families, as we have seen in the diagram. They occur in families of 3 to 4 members. The oldest being the furthest south. The one that is furthest from the south, then it is the oldest one. The one that is formed before. Now, these cyclones develop throughout the year. We need to note that the mid-latitude cyclones, they develop throughout the year. Now, the mid-latitude cyclones, they also reach South Africa more often in winter. The reason being that all the belts and the systems, they move slightly to the north in winter. That is why we are being affected by the mid-latitude cyclone. Let us look into the weather conditions associated with the mid-latitude cyclones. Let us look at the weather conditions. weather conditions associated by the mid-latitude with the mid-latitude cyclone. We're having the cold front here, and then we are having the warm front there. Let us look into the cross section of the mid-latitude cyclone. This is the cross section of the mid-latitude cyclone. This is because it is called the cold front. This is the cold front, as we can see. This is the cold front. And this is the warm front. You can see that the warm front is more gentle than the cold front. Look at the cold front. At the front, on this side of the cold front, we are having the formation of the clouds. And the type of clouds that are being formed in front of the cold front, they are the clouds called the cumulonimbus cloud. Obviously, it is only the cumulonimbus clouds where we are going to have the thunderstorm, where we are going to have a rainfall, meaning that it is from the cumulonimbus clouds that we can expect heavy rainfall. And then this side, we are having the two types of clouds that are formed on the warm front, altostratus clouds and the nimbostratus clouds. That will give rise to what? To a very soft rainfall. Now let us look into the conditions, weather conditions associated with the mid-latitude cyclone. What about the temperature? What about the temperature? The cold air is approaching, moving from west to east. Because the cold air is approaching the warm surface, where do we have the warm air? In front of the cold front, the temperatures are low. But when the cold front approaches, it comes with the cold conditions, hence the name cold front. So we are saying the temperature will decrease as the cold front passes over. The temperature will decrease. It will become very cold because the cold front is approaching. But when the warm front approaches, the temperature will increase. Why the temperature increases when the warm front approaches? It is because the warm air is approaching. The warm air is coming, meaning that the temperature will slightly increase because the warm air is approaching. On the other hand, when the cold front approaches, the temperature will decrease. It makes sense. When the cold front comes, then it will become more cold. When the warm front comes, it's obvious the temperature will increase. What about the pressure? What about the pressure? When the cold front approaches, the pressure increases. When the cold front approaches, the pressure will be high. There will be high pressure. And because we are having a low temperature, then the pressure will be high. The pressure will increase when the cold front approaches. But when the warm front approaches, the pressure will decrease. Why? Because the temperature has increased. Then the pressure will decrease. It makes sense. These are the weather conditions. The temperature, when the cold front approaches, the temperature will decrease. And when the warm front approaches, then the temperature will increase. The pressure, when the cold front approaches, the pressure will increase, will be high. And then when the warm front approaches, then the pressure will decrease, will become low. The humidity, the amount of water vapor, of water in the atmosphere, the humidity will decrease when the cold front approaches, and the humidity will increase when the warm front approaches. When the warm front approaches, the humidity will increase, and then when the cold front approaches, the humidity will decrease. What about the clouds formation? As we have seen in this diagram, that the type of a cloud formed when the cold front approach, it is a cumulonimbus clouds. It's a cumulonimbus clouds. Cumulonimbus clouds are formed in front of the cold front. Why? Because there is a rapid rising of the warm air. There is a rapid of warm air rising, and then the formation of the clouds is very intense where the cold front is found. Hence the formation of the cumulonimbus clouds. And what are the clouds formation in the when the warm front approaches? Altostratus as well as the nimbostratus. We're having the formation of the altostratus and the formation of the nimbostratus. What about the gradient? Can see here, the gradient here is steeper than the gradient of the warm front. The gradient of the warm front is more gentle than the gradient of the cold front. So we are saying the gradient is steeper in the cold front and the gradient is more gentle in the warm front. What about the type of a rainfall? Because of the cumulonimbus clouds, in front of the cold front, it's obvious that the resultant type of a rainfall is a heavy rainfall. It will be a heavy rainfall. And then because of the gentle gradient on the warm front, then the type of rainfall will not be as heavy as that one from the cumulonimbus clouds, but it will be a very soft type of a rainfall. Now, if you look into the rainfall, where we have the cumulonimbus clouds, is also be associated or accompanied by the thunderstorm with a strong wind, But we're having a soft rain from the altostratus and from the nimbostratus when the warm front approaches. Lastly, the wind direction. We are saying in the southern hemisphere, the wind will always change the direction in anti-clockwise direction. In the southern hemisphere, the wind will change direction anti-clockwise from northwest to west to south to southwest. You can see that the direction of the air is changing in this direction, anti-clockwise. This is called the baking. This is called the baking. The baking of wind. meaning it is the change of direction of wind anti-clockwise. And then in the northern hemisphere, the change of direction will then be called the veering. These are the conditions, the weather conditions associated with the mid-latitude cyclone. Let us go back again, where we're talking about the characteristics of the mid-latitude cyclone. We said the mid-latitude cyclone, they affect the land during winter. As we have seen, you can see. It affects the land in winter. The mid-latitude cyclone affects South Africa directly in winter, meaning that it moves over the land in winter. Now we're going to look at the impact on the human activities in South Africa. Remember, the cold front moves over the land in winter because all the systems, as we have mentioned, has shifted towards north. Now, what is the impact of the mid-latitude cyclone on the land? How does the mid-latitude cyclone affect the country? Because it affects us in winter, and then we are being affected by the cold front, it brings a very cold conditions in southwestern Cape and in the interior of the land in winter. Let us say it again. Because the cold front affects South Africa during winter time, and it is a cold front in its nature, it brings a very cold conditions. It brings a very cold condition, very cold conditions in Southern Cape. Not only in Southern Cape, but in the interior of the land in winter. It is already in winter, but when it comes along with a very cold conditions. In the southwestern Cape, and in the interior. Number two, the mid-latitude cyclone in winter, they bring a much needed rainfall in the area in winter. They don't come dry, as we have seen that it's in the cold front where we are having the cumulonimbus clouds, where we are expecting a heavy rainfall, meaning that the cold front in the southwestern Cape, it brings a much needed rainfall in winter. Much needed rainfall. In other words, to the farmers of the area, it brings joy. To the people of the area, it brings life. And lastly, when there is more rainfall, it sometimes results in floods. It sometimes results in floods. Learners, we are going to take a break. We'll continue after break. Thank you. Thank you, learners. We are starting again with our session. Remember that we ended where we are talking about the mid-latitude cyclones. Now, let us refresh our minds on the topic of cyclones. Remember, we have said the area of formation, it occurs at 60 degrees north and south of the equator. Remember again, we said it is along the subpolar low pressure belt. We said that is where the polar air meets the warm tropical air. We did mention the 4 stages of the tropical cyclone. Remember, the first one is the initial stage, where the disturbance starts to happen when the movement of the air starts to change. And then we went to the mature stage, where the features of the mid-latitude cyclones can visibly seen. Features like the cold front, the warm front, the warm sector, and the cold sector. I said that this is where learners are supposed to know what is happening. This is where the learners are supposed to know what is happening. Very much important to know the stages, especially the mature stage of the tropical, of the mid-latitude cyclone. I just want to remind you on that. The cold front, the warm sector, and the cold sector. Please do not confuse the names and so on. Then we said from the mature stage, we go to the occluded stage. Remember that the shape of the mature stage is not the same as the shape of the occluded stage, because in the occluded stage, that is where we are having what? We are having the occluded front added to that. And lastly, we talked about the dissipating stage. We said the mid-latitude cyclone is the only cyclone that can occur in families of 3 or 4. And we said the oldest, it is the furthest south. Then we said the mid-latitude cyclone can affect our country during winter. In summer, it is further south, as we can see. Then we said in winter, that is where it brings the coldness and the much needed rainfall. And then, if there is too much of rainfall, there will be the floods. That is the impact of the mid-latitude cyclones on the country. You might be asked a question like, the mid-latitude cyclones, it can bring the blessings to the people of the land, and it can bring the curse on the people of the land. Now, if you are to answer such question, you need to know about the blessing, which are the good things that happens to the person. Now, when we say a cold front or the mid-latitude cyclone as a system brings the blessing to the people of Cape, in winter, it means we are saying it brings the much needed rainfall. Because a rainfall is a nice thing. It's what we need. It's a blessing. It is out of the rainfall where the farmers, they can grow their crops. It is out of the rainfall that the residents can get water. It is out of the rainfall that the factories can function well. Rainfall becomes the blessing. But the curse, it is a bitter thing or the bad thing that can happen to the person. What are the curses of the mid-latitude cyclone? The coldness. No one wants to live under the cold condition. So we said the cold front comes with the coldness to the area and even to the interior part of the world. That means the coldness becomes a curse. Secondly, too much of rainfall results in the floods. The floods. Who doesn't know the floods? The overflowing of the water over the banks of the river. The floods. Who is not afraid of the floods? Surely, the floods, they become the curse. Because it's out of the floods where the lives become lost. It is because of the floods that the much needed infrastructure, the roads, the bridges, become destroyed. It is out of the floods where the crops that brings food to the people becomes washed away. It is in the floods where some diseases touches the lives of the people. That's how the mid-latitude cyclone can affect the country. Now, let's go on to our second topic, the tropical cyclone. Remember, a tropical cyclone is also a low-pressure cell. Just like the mid-latitude cyclone, it's a low-pressure cell. So the tropical cyclone and the mid-latitude cyclones, they are the low-pressure cells. And all the qualities of the low-pressure cells, they apply in both tropical cyclone and in the mid-latitude cyclone. The definition. You might be asked to define a tropical cyclone. We're saying a tropical cyclone is a small, intense, low-pressure cell that forms over the warm oceans. The definition, saying a tropical cyclone is a small, intense, low-pressure cell that forms over the warm ocean. It is a low-pressure cell, but it is the most powerful one, the most strongest one. It is the most dangerous one. Hence it is the intense, most dangerous low-pressure cell. It is even dangerous than the mid-latitude cyclone, a tropical cyclone. Please, learners, know the definition of the tropical cyclone. Before most questions can be asked about the tropical cyclone, you will need to define what a tropical cyclone is. Let us look into the place of origin of the tropical cyclone. The place of origin. The tropical cyclone, this is a place of origin. They occur usually in the oceans on the eastern side of the continent. The tropical cyclones are always found on the eastern sides of the continents. That is where they are found. Is the area of formation on the eastern side of the ocean. Why on the eastern side of the continent? Because the eastern side of the continent, the waters are warm. Hence, they can be formed there. They move from the equatorial regions towards the coastline. They move from the equatorial regions towards the coastline of the country. Tropical cyclones, they occur between 5 degrees and 30 degrees north and south of the equator. Some books, they are saying they occur between 5 degrees and 20 degrees north and south of the equator. That is the area of formation. Tropical cyclones are found between 5 degrees and 30 degrees north and south of the equator. Tropical cyclones are found on the eastern side of the continents where the oceans are warm. That is the area of the formation. It's different from the area of formation of the mid-latitude cyclone. This one, it needs to be on the eastern side of the continent from the tropical equatorial regions and between 5 degrees and 30 degrees north or south of the equator. Why? The question might say, why it doesn't start at the equator? Why there is no tropical cyclone formation at the equator? The answer is simple. At the equator, the Coriolis force is 0. So there cannot be the formation of the tropical cyclone on the equator. That is why it is between 5 degrees and 30 degrees, because it cannot happen in the equator, because at the equator, the Coriolis force is 0. But now in this case, we were looking at the area of formation. We're just looking at the area of the formation between 5 degrees and 30 degrees north and south. On the eastern side of the continent, where the oceans are warm, they are moving from the equatorial regions towards the coastline of the country. It's the area of origin, the place where they originate. Then from that, we look at the factors that give rise to the tropical cyclones. Areas that give rise to the tropical cyclones. 1, the temperature must be over 27 degrees Celsius. 4, the tropical cyclone to develop, it needs the high temperatures. High temperatures of over 27 degrees Celsius. For tropical cyclone to develop, we said they develop on the oceans. But the oceans must be warm. The oceans must have a high temperatures. For it to develop tropical cyclones, they need a high evaporation rate. High evaporation rate. Because the high evaporation rate, they cause warm air to rise into the atmosphere. High evaporation rate causes warm air to rise higher into the atmosphere. The other one, the presence of the Coriolis force. For tropical cyclone to develop, they need the presence of the Coriolis force. Remember, a Coriolis force is a deflecting force caused by the rotation of the earth. So, tropical cyclone, for them to develop, they need the presence of the Coriolis force. That is the reason why tropical cyclone develop between 5 degrees and 30 degrees north and south, because that is where Coriolis force operates. Dear learners, remember why they don't develop in the equator, because there is no Coriolis force at the equator. Coriolis force at the equator is zero. That is why they cannot develop on the equator. Why? They need the presence of the Coriolis force. Hence, they develop between 5 and 30. For the tropical cyclone to develop, they need hot, moist, and stable air. They need hot, moist, and stable air. Let us start again. Factors that give rise to the tropical cyclones. Factors that makes it easy for tropical cyclones to develop. Meaning, without those factors, we cannot talk about a tropical cyclone. 1, the temperatures must be higher, maybe over 27 degrees Celsius. The temperatures must be over 27 degrees Celsius. 2, because they develop in the oceans must be warm. That's number 2. Number 3, for it to develop, there must be high evaporation rate, because a high evaporation rate it causes the warm air to rise higher in the atmosphere. Number 4, for tropical cyclone to develop, they need the presence of Coriolis force. And then there must be hot, moist, and stable air. These are the conditions under which the tropical cyclones can develop. Maybe we can add the other one. Then we can say, for it to go on, it needs energy. For tropical cyclone to go on, it needs energy. And that energy comes from the latent heat. That energy comes from the latent heat. A latent heat is released when condensation takes place. We are adding another one. We are saying, for tropical cyclone to continue, it needs energy. It needs energy from where? From the latent heat. We call it latent heat energy. That latent heat energy comes when condensation takes place. These are the factors that give rise to tropical cyclone. Dear learners, whatever way the question might be asked, but if you have the feeling that it wants the factors that give rise to tropical cyclones, these are the factors. Let's go on. Can we look at characteristics of the tropical cyclones? Can we look at the characteristics of the tropical cyclones? Number 1, they occur between 5 degrees and 30 degrees north and south of the equator. We are already familiar with that. That tropical cyclones, they occur between 5 degrees and 30 degrees north and south. That's number 1. These are the characteristics of the tropical cyclone. things that the tropical cyclones are known of. We know tropical cyclones about, number one, they occur between 5 degrees and 30 degrees north and south of the equator. Number two, tropical cyclones, they affect the east coast of the continent. They affect the east coast of the continent. For an example, in South Africa like this will be at the east side of South Africa. This is the eastern side of South Africa, of the continent. So we are saying the tropical cyclones, they will always affect the east coast, meaning it will come from this direction and affecting the eastern side of the continent. Remember we said they develop on the eastern side of the continent. And now they affect the eastern part of the continent because they come from the east. That's number two. They affect the east coast of the continent. Number three, tropical cyclones develop during summer. Yes, during summer. Remember, we said mid-latitude cyclone occur throughout the year. They occur in summer. They also occur in winter. But listen, tropical cyclones, they only occur or they only develop during summer. Meaning, in winter, we are not expecting to have any tropical cyclone. The reason is simple. Temperatures. In winter, we are experiencing low temperatures. And we said one factor for the development of the tropical cyclone is that there must be temperatures over 27 degrees Celsius. So in winter, we can't have high temperatures. That is why we say tropical cyclone, they will develop in summer. The other one, they are smaller than the frontal depression, meaning the tropical cyclones are smaller than the mid-latitude cyclone in size. If you compare the area covered by the mid-latitude cyclone and the tropical cyclone, although they are both low-pressure cells, but the tropical cyclone, they are smaller than the mid-latitude cyclones in size. I believe you are with me. Once formed, once tropical cyclones are being formed, once they are there, once they have met the requirements, they will move from east to west. Yes. Tropical cyclones, once they are formed, the whole system, they will move from east to west. Remember the mid-latitude cyclone. The movement of the mid-latitude cyclone, it is from west to east. And the movement of the tropical cyclone, it is from the east to west. This is where, again, most of the learners confuse the two movements. Remember, mid-latitude cyclone, it is because of the westerlies. The word westerlies means from the west to the east. Tropical cyclone, they move from the east to the west, the opposite of the mid-latitude cyclone. Why? It is because they are pushed by the tropical easterlies. They are pushed by the tropical easterlies, meaning they are pushed by the wind from the east to the west. Hence we say once they are formed, they will move from east to west. Just like the mid-latitude cyclone, they also rotate in clockwise direction in the southern hemisphere, just like the mid-latitude cyclone. Remember, we have said that the two, they are the low pressure cells. The two are the low pressure cells. Therefore, the circulation of air in them will be clockwise. Tropical cyclones. They get their energy from the latent heat. Remember, we've mentioned this. They get their energy from the latent heat liberated in air condensation. Let's go back a little bit. For tropical cyclone to develop, they need Coriolis force, which is the deflecting force caused by the rotation of the Earth. But for the tropical cyclone to continue moving, it needs energy from the latent heat, which is produced in air condensation. The other one. Tropical cyclones are always given names. Tropical cyclones are always given names. Nothing like that in the mid-latitude cyclone. For an example, cyclone Eileen. That is the name of the tropical cyclone in that time. So, tropical cyclones will be given the names. The first letter of the name tells us how many cyclones there have been in that ocean area that particular year. Right. Whenever tropical cyclone is given a name, we look at the first letter. The first letter of the tropical cyclone Eileen is E. And E, it is the fifth letter of the alphabet. A, B, C, D, E. So we know that tropical cyclone Eileen, it is the fifth tropical cyclone in that area in that particular year. Sorry. Do you get it? Let's try to explain again. We are saying tropical cyclones are always given the names. For an example, cyclone Eileen. Look at the first letter. The first letter is E. And E, it is the fifth letter of the alphabet. Meaning that cyclone Eileen, it is the fifth tropical cyclone to occur in that area in that particular year. All right. Let us say we have Deborah, tropical cyclone Deborah. This is the name given to a tropical cyclone, Deborah. Now, look at the first letter. The first letter is D, which is the fourth letter of the alphabet. Then it means cyclone Deborah, it is the fourth tropical cyclone to take place in that area in that particular year. When the year comes to an end, when the new year comes, the first tropical cyclone will be given the name starting with A, because it will be the first tropical cyclone in that particular year. Maybe it will be cyclone Alina. Maybe it will be cyclone Abel, because it will be the first. So please, learner, look at the first letter of the name. The question might be, in the tropical cyclone Eileen, how many tropical cyclone has passed? Because this one is the fifth one, it means the tropical cyclones that have passed, they are 4. You get it? Yes. Just like that. These are the characteristics of the tropical cyclones. Remember them. Let us continue. Just like the mid-latitude cyclone, tropical cyclones also has got stages of development. Let us look into some of them. The initial stage. In the initial stage, or in the formative stage, the pressure is still above 1,000 hectopascals at the center, and then they are falling rapidly. Look at the center here. Do you see the high pressure? It's 1,002. It means it's above 1,000 hectopascal. It is an initial stage. It is in this stage where the eye is starting to form. The eye is the center of the cyclone. From the initial stage, we go to the immature stage. Then in the mature stage, the pressure is below 1,000 hectopascals at the center, and it continues to fall. In the initial stage, the wind were gale force, but in the immature, the wind becomes the hurricane, reaches the hurricane strength, very stronger than the gale. And the area covered by the hurricane is 30 to 50 kilometers from the eye. That's the area covered. If you go to the mature stage, you can see now that the pressure is now below, much more below the 1,000 hectopascal. Then the pressure has stopped to fall or to decrease. In the initial stage, the pressure was above 1,000 and it was falling. In the immature stage, the pressure was below 1,000, but it was still falling. But in the mature stage, the pressure is low above, it is far below 1,000, and it has stopped to fall. Now, the area affected by the hurricane strength increases. It's extended to 300 kilometers from the eye, meaning that the area covered by the tropical cyclone is now bigger than the area covered by the tropical cyclone in the immature stage. It is in the mature stage where there is a heavy rainfall from the cumulonimbus clouds. And then the worst weather is experienced in the forward left-hand quadrant. Look at the shaded area. This shaded area, it is called the left-hand quadrant. It is a very dangerous site of the tropical cyclone. Remember, we said a tropical cyclone is a very intense low-pressure cell, meaning it is a very dangerous low-pressure cell, dangerous than the mid-latitude cyclone. This is the head of the tropical cyclone, the area shaded. Those are the stages. Then from the mature stage, we go to the decaying or the degenerating stage, the dying of the tropical cyclone. Remember, we said in the mature stage, we are experiencing a heavy rainfall. Remember, we said we are experiencing a heavy rainfall from the cumulonimbus clouds, meaning we are experiencing the thunderstorms in the mature stage. And we are experiencing the worst weather in the mature stage, meaning the tropical cyclone has reached the maturity. From that stage, there comes the decaying or the degenerating stage, where we said in the mature stage, the pressure was far below 1,000. Now in the decaying stage, the pressure begins to rise, begins to increase. And we are saying there will be a reduction in the area affected. Remember, in the immature, a certain area was affected, 30 to 50 kilometers. But now in the mature, the area became larger than that, to 300 kilometers. But when it reaches the decaying stage, the area affected becomes small. Now we know now that the tropical cyclone is about to die. In many instances, this occurs over the land, meaning that the dying of the tropical cyclones takes place over the land. And then it dies over the land. I just want us to look into the question, what happens when the tropical cyclones reach the land? What happens when the tropical cyclone reaches the land? This is the one. What happens? Tropical cyclones usually die out when they reach the land. Even if when it comes over the ocean, being so strong, being energetic, full of energy from the latent heat, immediately when the tropical cyclones reaches the land, in most cases, it dies out. Yes, maybe after causing a havoc, maybe after causing a great destruction, but ultimately it will die out when it reaches the land. Why does the tropical cyclone die when it reaches the land? Why? That would be the question. Explain why the tropical cyclones die when they reach the land. 1, the winds are slowed down by the friction of the land surface. Remember, when the tropical cyclone came, being strong over the ocean, the friction is much less over the ocean. That is why the tropical cyclones are able to move a great distances over the oceans. But immediately when it reaches the land, the friction increases. Friction from the land surface. When that happens, it causes the tropical cyclone ultimately to die. The friction over the land is more than the friction over the sea. Note that. Why tropical cyclones usually die out when they reach the land? 2, the drier air enters the system. Remember, for tropical cyclone to develop, we were saying it needs warm air, the rising of the warm air. Now, when the tropical cyclone reaches the land, dry air enters the system. When the dry air enters the system, it reduces the amount of condensation, and therefore the amount of energy also will be reduced. what will happen when the condensation is reduced and when the energy is also reduced. What will happen? The tropical cyclone is going to die. Please, learners, remember that what will happen to a tropical cyclone when they reach their land, they will die out. Why will they die? Remember about the friction, which is more over the land, and remember about the dry air that will enter into the system, causing low condensation and causing low energy, ultimately causing the tropical cyclone to die. We are answering the question, what happens when a tropical cyclone reaches the land? Now, how can we recognize tropical cyclones on the synoptic weather map? How can we recognize the tropical cyclones over the land? Look, this is the synoptic weather map. Look at the eastern part of the map. We have a low pressure system here. This is a low pressure system. Now, how do we recognize this low pressure system as a tropical cyclone? One, the symbol of the tropical cyclone. The symbol of the tropical cyclone. This is the symbol of the tropical cyclone. This is a low pressure cell. This is a low pressure cell. It doesn't have a symbol. A mid-latitude cyclone is also a low pressure cell. It doesn't have a symbol. But when it comes to the tropical cyclone, here is a symbol. It is through this symbol that we know that it is a tropical cyclone. The symbol of the tropical cyclone. Number two, the date of the map. Look at the date of the map. The synoptic weather map in front of us. The date is 22nd February, the year 2000. February, the year 2000. The date of the map, because it is in summer, will indicate the presence of the tropical cyclone. Remember, one of the characteristics of the tropical cyclone is that they occur in summer. So when you look at the date of the map and you look at the symbol, they will agree that it is a tropical cyclone. Number three, the name of the tropical cyclone. Remember we said it is only the tropical cyclone that are given names. We even made an example of cyclone Eileen. The name of the tropical cyclone will always be printed along the eye. Let's look into this one. This is Eileen. Next to the eye, in the center of the tropical cyclone, this is the name. It is only tropical cyclone that has got the name. Then, the circular pattern of the isobars, like all other low pressure cells, which are made up of the circular isobars. The tropical cyclone also has got the circular isobars. This is how you can recognize the tropical cyclones on the synoptic weather map. Remember, they might ask you the question, how can a tropical cyclone be recognized on the synoptic weather map? Remember the symbol of the tropical cyclone, remember the date of the map, remember the name given to the tropical cyclone. Remember, it has got the circular pattern of the isobars. Let us now look at the structure of the tropical cyclone, the cross-section of the tropical cyclone. This is the cross-section of the tropical cyclone. It is different from the mid-latitude cyclone. Do you see any cold fronts here? No. Do you see any warm fronts here? No. Do you see any warm sector here? No. Do you see any cold sector? No. Lena, do you see any occluded front? No. This is the structure, the cross-section of the tropical cyclone. Look at the center of this. We are having an eye. Like we said, an eye, it is the center of the tropical cyclone. The eye, it is the center of the tropical cyclone. The center of the tropical cyclone, it is called the eye. Look what happens at the eye. Look what happens at the eye. The eye is the center of the tropical cyclone. It is a small area up to 50 kilometers wide. The small area of the 50 kilometers wide. Now, the conditions in the eye, they are calm. It has a calm conditions. Cloudless, free of wind and rain. You might ask me a question. You said a tropical cyclone, it is a very dangerous low pressure cell. But how it comes that you talk about the calm, at less, free from wind and rain conditions? The answer is simple. This is happening at the center of the tropical cyclone. It is the safest area in the tropical cyclone, meaning that if an area can be hit by a tropical cyclone, where the center is, where the eye is, that will be the harmless area of it all. Why? It will be a calm area, no clouds, no rain, no wind. Those are the conditions at the eye. Listen to this. Completely around by the cloud masses and ranging storm, meaning the eye, it is surrounded by the very massive cumulonimbus clouds with the ranging storm. Let's go back to our diagram. These are the eye walls. These are the eye walls. They are made up of the cumulonimbus clouds. See, we have the cumulonimbus clouds surrounding the eye. And then in the cumulonimbus clouds, remember, that is where we expect to have the thunderstorm, a heavy rainfall. These are the dangerous places in the tropical cyclone. To be safe in the eye, look at the gentle air sinking from the upper high pressure cell. The air is sinking. So in the sinking of the air, there can never be the formation of the cloud. If there are no clouds, there can never be rainfall. That explains why in the eye we are experiencing the calm conditions. This is the structure of the tropical cyclone. Dear learners, this is again the point where you need to take all the marks. Do not throw away the marks. Let us now look at another portion the global occurrence of the tropical cyclones. The global occurrence of the tropical cyclones. We are saying the tropical cyclones have different names in different parts of the world. Different names to different parts of the world. In the West Indies, in the Gulf of Mexico, and in the United States, remember, tropical cyclones, they are known as the hurricanes. It doesn't mean it is something different. It is still the cyclone. It is only the name that they are calling the tropical cyclone with. It's a hurricane. But in the India, in the Madagascar, and in Mauritius and South Africa, we are calling it a cyclone. Look at in China and in around Japan, they call it a great wind, the typhoon. Very great wind, typhoon. Look at Australia. They call it willy willy. It doesn't mean we are talking about the different systems. No, it's same system, but different names in different parts of the world. Can we briefly talk about the weather associated with a tropical cyclone? Can you think a little bit about the tropical cyclone? How dangerous it is? Can you think about the weather conditions that can be associated with the tropical cyclones? Let's look at some of them. Tropical cyclones are typically associated with a torrential rain, a heavy rainfall. Heavy rainfall. That is why they cause so much destruction. Another one, the heavy rains on the land, they cause surface soil to become saturated, resulting in the increased runoff to the rivers, to the wetlands, and to the dams. More water runs to the rivers, to the dams within short space of time because of tropical cyclone. There will be the strongest winds and heaviest rainfall that will be occurring in the eye wall. Remember, the eye wall is formed by the cumulonimbus clouds surrounding the eye. They are going to experience the storm surges also that will become so destructive. There will be large waves in the oceans. Dear learners, at this point in time, I just want to say to you, thank you for listening to this lesson. And good luck in your coming examination. I know you are going to make us proud. I thank you.